Oh, this is when the jacket comes off.
Is this the X-rated version?
Already tacked over here.
Woo!
Okay, Mr. Nero, let's get a junction. What have you got? Okay, so you have the thingy up here that holds the calcium.
What is that called?
Terminus
Neurosecretory.
cisternae
Those
or
are the
something like that?
neurosecretory vesicles, and that would be in
Nope, the
the.
terminus cisternae is different than the
Axon?
bulb. Motor end bulb. The terminal cisternae is different than the motor end bulb.
Yeah, because that's the one that's inside. That's after. That's coming. It's in the sarcoplasmic reticulum.
Right.
That's where they're releasing the calcium inside of
Right.
the muscle.
Right.
Whoop.
Okay, so what happens is you have stimulating action, which in this case is electroimpulses through the nervous system, into the motor end bulb. Right here it is. And then you have the, what's that called?
The synaptic
Motor
cleft.
and
Synaptic cleft.
Oh, synaptic cleft.
And then you have this area here.
Motor end plate.
Oh, this is synaptic cleft, motor end plate. You were
Motor.
right.
Okay, the
Other way
motor.
around.
Okay, so I had it. Okay.
Motor end bulb, synaptic cleft, motor end plate. Right? And on this motor end plate are the little receptors. Okay? So what happens is you get the neural signal, and then the, what are these?
Neurosecretory vesicles.
Neurosecretory vesicles actually rush to the end and bond with the membrane of the motor end bulb, which opens it up, and they release
Acetylcholine.
Choline.
Acetylcholine bonds with these receptors in the motor end plate, right? And says, time to do muscle work.
Power
So
bar.
what these
To pump, eat pump.
do is it now sends,
Signal.
what it actually does is it reverses the polarity of the motor end plate, right?
Right.
So the
That's
motor
all
end
the
plate
low
has a
voltage.
positive charge because of the atomic structure, and then it runs all the way down to the T tubules over here, which also have a positive charge. So once you start bonding, it changes the charge and sends a sort of wave of negative charge all the way down both sides into the T tubules, right?
Right.
And then they stimulate the
Sarcoplasmic reticulum.
sarcoplasmic reticulum, where you have this up here, which is the,
Terminal cisternae.
right, you have the terminal cisternae, and that releases calcium. So now we're going to zoom in a little bit over here.
Okay, we're zooming.
So you have the myofibril with its actin and what you call it,
Myosin.
myosin, sarcomeres. And then you have the reticulum that comes out like that, or whatever. So it starts releasing calcium, and in these actin strands, there is sort of a wrapper, tropomyosin, which covers the receptors, the calcium receptors. Or not the calcium receptors,
Yeah.
the myosin receptors. So the calcium hits this tropomyosin, and it sort of retracts, opening up the receptors on the actin filaments, right?
You're right.
And then
It binds to the troponin.
myosin,
Binds to the actin's open site. or-
right?
Oh,
So
myosin.
myosin binds to the actin's open site, and myosin just sort of free floats in the cell. Like it's there. It's always there, right? So myosin starts bonding to these open sites and forces it to contract, right?
In one direction.
It's always
Yeah,
going to
pick
bring
one.
the Z discs inward
In.
toward the M line.
Right. So,
Oh, okay. So that's two things.
so you,
Okay,
right.
got
So
it.
you have these Z discs
I
up
thought
here
it was-
and these
okay.
actin filaments.
I thought it was-
They're literally like accordions. They're gonna.
So you're going to have an overlap of actin and myosin.
Right. So instead of looking like this, it's actually going to look more like this.
Yeah.
Is that when it shortens the H band?
Yeah.
Ooh, I'm smart.
And then when contraction is over, the cisternae actually reabsorbs the calcium. Now, we don't really need to go too deep into it, but there's an actual mechanism on the outside of the cisternae, like in the membrane.
Is that called a triad?
No, the triad holds the.
Actually,
Yeah, that's
it's short to IMAD, and the H zone disappears.
I want this all on video because I'm gonna watch it tonight. The H zone disappears.
There's a
I am.
mechanism on the membrane of the cisternae that actually polarizes to attract the calcium ions.
But we don't need to know all that, right?
So
Well,
stop
it's
being
in there
overly
somewhere.
smart, overachiever.
But what you need to know is that this sucks the calcium back up, and once it does that, this unwinds and covers the receptor sites again, and then it begins to relax.
Basically, everything we're saying right now, there's going to be like one or two random ass questions that are going
Well,
to
this is for the story.
Hey, I remember that.
Yeah.
This is for the story of contraction, which is a key here.
Neuromuscular.
The story of contraction
Well,
like has 5 steps.
William,
Yeah.
Yeah.
did
You
you
wanna
go
go
over
into
what
it?
He did.
initiates that end bolt to like
Yeah.
the calcium in there? Or no?
Well,
Did you
Yeah,
mention
we did that.
Okay.
Yeah.
Where's the triad?
That's the coil around the actin
Okay.
that covers
The
the receptor sites.
tropomyosin, troponin,
What was
and
the
actin.
question?
So,
The
wait,
triad?
are you talking about the triad?
A
Is
triad
the
is a
T-tubule.
T-tubule
Oh.
and
It's a
two
T-tubule.
sarcoplasmic
Two
reticulums.
cisternae.
Yeah, it's a
Basically, you have a T-tubule in the middle and two sarcoplasmic reticulums on the side.
Yeah.
That's
And the
a
triad
hence the name
is where-
triad.
That's
the
the
triad.
same thing.
Oh, that's
the
a triad.
Triad.
Oh,
It's the two SRs and the T2.
Yeah.
Okay.
Yeah.
So
Look at a T
So
cell,
there's
look
something
at
in
both
here,
sides and it's-
because now you have all this. What's the A?
Acetylcholine.
Acetylcholine.
You have all this acetylcholine in here, and there are actually enzymes. So once these release and we're done, we don't want to contract anymore. We're over. There are enzymes that start eating up the acetylcholine
Right.
and actually breaking it apart into acetylcholine and choline, right?
Yeah.
It's acetylcholinease that breaks them apart.
Right.
woo. Very good.
For the purposes